Guys, welcome to YouTube channel Foundation JEE. Today's lecture is on gravitation. Gravitation means guys Gurutvakarsan. This is a kind of force which is acting between two masses. Guys, due to gravitation, our planetary system or universe exists. What shape we see today? Okay, we will study about this thing in this lecture. So first we see in deep about gravitation, then free fall of a body due to gravitation, and what is g, that is acceleration due to gravity or gravitation near earth surface, and how the value of g, acceleration due to gravity, varies when we are moving up from earth surface and when we are going towards the earth center, and when we are moving from pole to equator on earth surface. All things we will discuss in this lecture, and after learning all these things we will solve one numerical problem based on the formula we derived in this lecture. Guys, now here time to see what is gravitation. So see gravitation. So gravitation, it is a natural property of mass, or you can say matter. Okay, so what this natural property says? It says every mass of universe attract to each other. Okay, now we will see this one in our planetary system. Okay, now suppose this one is our earth. Okay, now earth, or this one is a moon. Okay, what's happened here? One force of attraction. Okay, means that gravitation क्या है? एक force of attraction. Okay, so guys, here earth attracts moon towards its center. Okay, suppose like this one. Okay, and moon also here attract earth towards its center. So see, it is a natural property of mass, means you have not to say any mass to attract this one. It is its inherent property, means when it start to becomes a mass, then it start attracting to other mass. Okay, now see, earth is attracting this one. Okay, what's happen if this is not attracting? means earth, then see this motion of our moon is like here this one. Okay, what's happened if this force of attraction is not available, then this will move like in this direction. Okay, so velocity of moon will be in a straight line, or you can say tangential direction. Okay, so one force is attracting, that's why you can say the moon is revolving around the earth. Okay, so this is only possible due to gravitation. So one question in your mind, that sir, how this force is balanced, because mass of our earth is greater than mass of moon. Okay, so it must attracted towards this one, or it must collide. But guys, you know, here sun is also available. Okay, another planetary system, Mars. Okay, etc. Planetary system available in sky. Okay, so as a natural tendency of a mass, so sun is also attracting this moon towards itself. Okay, and Mars is also attracting towards itself, or moon is also attracting Mars towards itself. So what's happened, the net force acting on this moon is now zero. So whatever the distance it is, initially it maintains. Okay, so we read in our earlier chapter about inertia. It says, guys, it is a natural tendency of an object to remain in rest condition or moving condition with same velocity, unless we don't apply any external force. Okay, so see, in the case of our moon, whatever the planetary system, they are applying the force on moon, so net force is zero, or now it balance at a certain position from earth surface. Okay, so it is revolving towards earth. Okay guys, due to the gravitation only, all our universe, you can say all stars, planet are hanging in sky. So you can also say, sir, due to gravitation all stars, planet, or you can say galaxy hanging in sky. Okay, so gravitation is, guys, what you can say, attraction. Attraction is what? Force of attraction. So what force of attraction is exerted by one mass to another mass is called, guys, universal law of gravitation. So what is this force? Okay, we will see next. Okay, so universal law of gravitation. Okay, so this law say, guys, okay, consider two mass here, m1 and m2. Okay, now this one is its center, this one is its center. Okay, suppose distance between these two center is d. Okay, so it say, guys, so the force of attraction acting between two masses is proportional to product of their masses and is inversely proportional to a square of their distance. Okay, guys, here distance is distance between their center of mass. Okay, for your classes, just you remember distance is here center to center, distance between two masses. Okay, however, just you see some insight about the center of mass. Center of mass of an object is average mass of an object at one particular point inside the object. Okay, so you can say, sir, where we apply this one. Okay, now see, this one is spherical, so you can say the center is like this one. Suppose the shape is different now. Okay, it is now triangular. Okay, so in this case, how you will calculate the center? Okay, so when you will go at higher classes, then you will read this one is a side, then take a midpoint, or this one is vertex of this triangle, so take a line segment, take a midpoint this side, so this one join, or this one suppose midpoint, so this one is a here point of intersection of all the point. Okay, this is midpoint. Okay, so you can say this point is here center of mass. Okay, so when you join all the meridian, then you will get the center point of this triangle. Okay, so this way you can calculate center of mass. Okay, so you will read it in higher classes. Okay, now come to our definition. Here the first statement say this force F is proportional to product of their masses, so m1 into m2. Now second statement say this one is inversely proportional to square of their distance. So 1 by here d square. So d is what, guys? This one is here center. Okay, so d is this one. Okay, so always remember about the shape, and when you count down or when you consider the center. Okay, now guys, in physics, maths, or any chapters, okay, when you omit this proportional sign, okay, and equating this one, then you have to put one proportionality constant. Okay, so this constant is not depend upon whatever the quantity you have taken. Okay, this value is independent of these quantities. Okay, so its value is calculated by experiment. Okay, now this value is G. Okay, this is capital G. So this capital G of proportionality constant has one name. Okay, this, okay guys, so what is its name? Its name is gravitational constant. Okay, so see, so guys, G is known as gravitational constant, or its value is 6.673 into 10 to power of minus 11. This is Newton meter square or kg to power of minus 2. Okay, so you can say force between two masses is this one. Okay, so guys, this one is a force of attraction acting between two object. Okay, so suppose here is earth, okay, or here is suppose a star. So we can say force of attraction is acting between these two. So our answer is yes. Okay, so each masses in universe attract to each other. Okay, with this force. Okay, so in your mind one thing is coming, sir, why not there is an effect of this gravitational force of a star on earth? Okay, so guys, the distance is too much more, you can say in light years. Okay, so the force is negligible. Free fall of body near earth surface. Okay, or you can say whatever the gravitation present on earth. Okay, now guys, suppose this one is our earth. Okay, or one body here whose mass is m, or center of earth is here what, O. Okay, or me, mass of earth. You guys know the radius of earth is r. Okay, here guys, see, air is also present surrounding to our earth surface. Okay, so here we neglect resistance due to air on body. Okay, now suppose here this distance in meter or only few kilometer. Okay, then we neglect this distance. Okay, why? Because r is a radius of earth. It is 36370 kilometer, or we general write this one 64 kilometer. Okay, m is in meter. Okay, 100, 200, okay, or 1000, 1200 meter. Okay, etc. Okay, so if you will make an addition here, so what's happen, you see, this is in 100, so it is approximately value will be what, guys? In meter only. Okay, so we neglect this 100 meter or this one. Why? Because now when the object is falling towards the earth due to its gravitation, okay, so we can write here formula for force of attraction by earth on object equal to F equal to G M E M or R E square. Okay, now you know G is a gravitational constant whose value is, guys, what? Newton meter square kg to power of -2, or this is Me equal to actually 5.98 10 to power of 24. Here we assume this is 6 to power of 24 kg and kg. Okay, now Re we assume here this is 64 kilometer. Okay, now we read in our earlier chapter force and laws of motion, or you can say second law of motion, second law of motion, or you can say Newton's second law of motion. When an external force is applied on any mass, then it is equal to m into a, where F is force applied by external force, or m is mass of body, and when you apply the force push or pull, then it get accelerated. Okay, so when we equivalent this to 1, then what you will get, see here, we can write F equal to G M E M, and this one RE square, or this one MA. Okay, now see, this MM cancel out, or A equal to coming GME RE square. Okay, so only the force acting on object is due to gravity, means the earth gravitational force. So A is replaced by here G. Okay, or G equal to ME or RE whole square. So now see, this G is independent of now mass. Okay, if we put a value this one G value 10 to power of minus 11, mass of earth 6 10 to power of 24, or Re 6.4 into 10 to power of 6 whole square, then it is coming 9.8 meter per second approximate, or in some books you will see this one meter per second square. Okay, now so this G is known as, guys, acceleration due to gravity. Okay, so why? Because this acceleration is created by earth gravitational force. Okay, so this is a small g, or this one is a capital G. This is known as a gravitational constant. Okay, so you remember this value in universe is constant. However, this G value is varies due to planet. Why? Because see here, mass of the planet and radius of planets are also coming in picture. Okay, so it is not necessary all over in universe the G will be same, because mass and radius of the planet changes when you consider any planet. Okay, now so I think the acceleration due to gravity clear to you guys. Okay, now could we say the G all over the earth surface is equal, or it may vary? So see, if this R here nearer to earth surface, then G value will be all around same. However, the M mass may be vary. How? Suppose this one is a earth, okay, or this one is a center. If you make a tunnel, okay, so when you are going inside this earth center, so O, then its value also decreases, because see, when you are here, okay, then what's happened, the other masses are around to you. Okay, and radius also here decreases r. Okay, so see how the value of G, acceleration due to gravity, when you are going in up direction or when you going in down direction from earth surface, or when you are moving along the surface of the earth. Okay, see this one, variation of G, which is known as acceleration due to gravity. Okay, here is consider this one is a earth whose center is O and radius now RE, or the object is at height h from the earth surface whose mass is m. Okay, so how much force is exerted by this earth on this mass, and this time we write here G MEM, or now we write here H plus RE whole square. Okay, and the object is when near to the earth surface. Okay, then this is equal to this one. Okay, so if this one is 1, or this one is 2, or this one is f1, or this is f2, why? Because see, here denominator is different from this one. Okay, so when we say here acceleration is g naught because m mass of object in universe is constant. Okay, so this value you see cancel out, or this is re plus h whole square, so cancel out, so z naught value will coming like this one. Okay, or this g value will be this one. Okay, so now this is one equation, this is two. Okay, so when you divide like 1 by 2, then what's coming, guys? This is re square, or this one re plus h square. Okay, why? Because see here the term gme and this is gme cancel out each other. Okay, now so you can say, sir, g naught equal to g whose value is known to you, or this one re plus h or whole square. So see, when you are going above to the earth surface, then h is high, then it will be at some value. Okay, suppose here h equal to re by 2. Okay, then what will be the value of g at that time? See, when you put this value here, so re whole square or re plus re by 2. Okay, or whole square, or this one is g naught by g. So this is, guys, now you can write 9 re whole square by 4. Why? Because 2 plus 1 3, 3 whole square, or this is 2 4. So see, this one is cancel out, or this is z. So 4g by 9. Okay, g naught. Okay, so see how the value of g now decreases by factor 4 by 9. Then we will go up half of the radius of the earth surface. Okay, now this one is variation of g when you are going up direction from earth surface. Next we will see how the z will vary when you are going inside the earth. Okay, see the variation of g, that is when we are moving from earth surface towards center of its. Okay, now consider here earth. Okay, now this one is its center. Suppose we imagine we have made one tunnel. Means what, guys? Tunnel or surang. Okay, so suppose you are here or any object is here, then when you are start traveling from here towards the center of earth, then how the value of g varies. Okay, so here radius of earth is, guys, r. Okay, now suppose you are at a distance d from earth surface. Okay, then the value of g naught means the acceleration at this point. Okay, here consider dotted line. So only the spherical mass available is in radius r minus d. Okay, so the force of attraction fully due to this spherical part is this one. However, some portion of earth are also available, so they also attract, or you can say apply a gravitational force. Okay, so when you will go in higher classes, then you read or derive this formula that gravitation at this point, where we assume z naught equal to g into 1 minus d by r. Okay, so what you see when you are at earth surface, so d equal to 0, so g naught equal to 1 minus 0, so this is g into 1 or g naught equal to 0. Okay, so what you see here, g naught equal to g. So next guys, here suppose you now start traveling from here to here, then your distance d becomes r. Okay, or you are at center of the earth, so g naught equal to g 1 minus r by r, where r is radius of the earth. Okay, re. Now this becomes g 1 minus 1 or g into 0, or this is 0. So what you get here, at the center of earth, the value of g acceleration due to gravity is 0. So one important point you remember by seeing these two, one or two, that when we start moving from earth surface towards its center, then value of g acceleration due to gravity decreases. Okay, what's happened guys, when you start traveling from here to here, okay, pole to equator, so see this one, so a variation of g when we start moving pole to equator. Okay guys, suppose someone asks to you what is the shape of earth, so can we say the shape of earth is spherical? So our answer will be no. Why? Because earth shape is oblate spheroid. Okay, what does mean? Means at pole, okay, the earth is flattened, means थोड़ा सा चिपटा हुआ है. Okay, here this one is a pole. Okay, or this one is a equator. Okay, so what you notice here, the value of r. Okay, here the radius, or you can distance from center to the surface at this position, pole and equator, is not same. So if this one is say R1 or this is say R2, okay, so what's happened, the value of G equal to what you guys know, this is R square. Okay, so at pole the distance between center and surface is small. Okay, so R1 value is small compared to equator R2 value. Okay, so here see R2 is greater than R1. So when you put R2 here, then you will see guys G will be less. Okay, and when you put R1, so G will be more. So you can conclude when we start moving from pole to equator, then value of G decreases. Okay, or G value is guys 9.8 meter per second square. Okay, so this one is important fact, you have to remember it. Okay, so guys we will see one numerical question for your better clarity about gravitation. See, find mass of planet whose radius is 3200 kilometer and acceleration near its surface is g by 3, where g equal to 9.8 meter per second square. Okay, so what will be mass of that planet? Okay, so solution guys, here as you know the value of G equal to G M E or R E whole square. Okay, now where M E mass of earth or R E radius of earth. Okay, and we know this value is 6400 kilometer, or we also assume here mass of earth is this one. Okay, now in question it is given that acceleration due to gravity at that surface of planet is g by 3. So here this gravitational constant, or if mass of planet is mp, okay, or radius is rp, okay, then raise power of 2. Okay, so guys if this one is equation 1 or this one is equation 2, divide equation 2 by 1. Okay, so what's happened, this is g by 3 or this is 1 by g, or this is g capital G or mass of planet, or this is r p whole square into re whole square, or this is g or mass of earth. So gravitational constant cancel out. G, acceleration due to gravity, Gg cancel out. So 1 by 3 equal to mass of planet, mass of earth, or you can write this one whole square, or this is multiply. Okay, so Rp value is what, guys? Re by 2. So when you put this one, then this becomes here Re, or this is Re, or into 2, or whole square. So this one cancel out. So 1 or 1. Okay, now you can write, sir, mass of planet equal to me by 12. Okay, so you know this value is 10 to power of 24, or divided by 12, or just take this is 60, or 10 to power of 23, or 12, 1 or 5. So mp. So mp, mass of planet, equal to 5 into 10 to power of 23 kg. So guys, now hope the concept of gravitation and how our planetary system or universe exists due to gravitation, universal law of gravitation, free fall of a body due to gravitational force, and variation of g when you are moving up from earth's surface going towards the center of the earth and moving along the earth. Now clear to you. So in next lecture, guys, we will come with a motion equation of object when falling under gravitation, and see what is mass and weight. Okay, so if you guys think this lecture is informative for you and others, so please like and subscribe this YouTube channel, Foundation JEE channel, and also share to your friends and family. Guys, as I just said that I will come with a new lecture on gravitation. So if you want to be updated for my next lecture, so please on your YouTube notification. So once again, thank you very much for listening and watching this lecture. Thank you very much.